So today we're going to be taking a look at quadratic functions. That's our next unit. A quadratic function is any function that has a power of 2. And there are several different forms of a quadratic function. The first is standard form, when you've got ax squared plus bx plus c. Now a, b, and c are numbers, so an example of a quadratic function in standard form might be y equals 2x squared minus 4x plus 9. So again, a, b, and c are numbers, not variables. X and y are the two variables. Vertex form is when you have a function that has a quantity squared, quantity being x minus h. So again, this might look like y equals negative x plus 3 squared minus 1. So the plus and minus, the minus h plus k, don't necessarily always have to be positive and negative. What the vertex is of this function, and we'll talk about a vertex when we get to graphing, the vertex of this function, for example, would be negative 3, negative 1. So if you had me first or second try, when we talked about the asylum, it was second trimester with the point slope form. If you look at that x plus 3 in parentheses, anything grouped with the x is in what I call the asylum. When it's in the asylum, it doesn't act normal. So it looks like a plus 3, but the vertex is really negative 3. Outside the asylum, that minus 1 is normal, so the other coordinate for the vertex is negative 1. So inside the asylum is not normal, becomes negative. Outside the asylum is normal, stays the same sign. And that's the form that we're going to be working with today. The last form is factored form, and factored form gives you the x-intercepts of the graph. So that's why we have x1, x2. Again, those are numbers. So this might look like y equals 12 times the quantity x minus 3 times x plus 1. Alright, so the first thing that we need to know in order to graph quadratic functions is what the parent function looks like. The reason it's called the parent function is because it kind of gives you the shape or the idea. It's kind of the originator of all of the other quadratic functions. They are based off of this most basic type of quadratic function. So off to the right here we have the steps to the process that we're looking for. So our first step in graphing our function is to create a t-table. So we're going to set up x, y values. And the x, y values you want to choose are some positives and some negatives in order to see what the graph does on both sides of the y-axis. So I like to do negative 2, negative 1, 0, 1, 2, because those are relatively easy numbers to work with. Once you have your x values, you substitute them into the function and solve for your y value. So if I take negative 2 and square it, I get positive 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So then we're going to plot those ordered pairs. So we have x, y coordinates here. And we'll try and connect the points and see what the shape of this function looks like. So we've got negative 2, positive 4. Negative 1, 1, 0, 0, 1, 1, and 2, 4. So if you notice by looking at the points, we can't connect them with a line. If I were going to start at 0, 0 and make a straight line through that point, it wouldn't hit my other point. Same off to the left. So what we have to do instead is make a curve. Off to both sides of the origin. So the graph of a quadratic function, it's got a special name, it's called a parabola. And notice how at 0, 0, this is not a point, it's a curve. The graph of a parabola is a smooth curve at the vertex. This is what's called the vertex of the graph. And it's where it changes direction. So if we were going to graph this with one curve, I kind of made two curves, we would come down, and we're coming down, down, down until we change directions at the vertex to go back up. Always make sure that you've got arrows on the end of your parabola because it continues increasing forever in both directions.